Welcome students to the last capsule of this topic, strength of materials, having 100 sample MCQs for the end semester exam with LMR. And the capsule 7 is on the topic principal stress and strain. So let us start with LMR for this particular topic, starting with the definition itself. So principal stress and strain. What is meant by principal stress? So in any loaded member, there exists a three mutually perpendicular planes on which, this is important point, shear stress vanishes or becomes zero. That plane are called as principal planes, and the normal force acting on that principal plane are called as principal stresses. So first of all, we need to find out principal plane, and the plane on which shear stress is zero, that is known as principal plane, and the normal force acting on that plane is nothing but the principal stress. Now going to the principal strain. In an undeformed member, there exists three mutually perpendicular line elements that remain perpendicular after the application of load. These three elements are called as principal strains at the point. So if you see the diagram, it is like this. So here you can see in this particular element, if shear stress becomes zero, that it is known as at any plane. If you can see this plane, there are no shear stresses here. There is only sigma 1 and sigma 2. There are no shear stresses. So these planes are known as the principal plane, and these are known as the principal stresses sigma 1 and sigma 2. Again, we have some formulas for finding out principal stresses and principal strain, which is like this. So principal stresses sigma 1 and 2 is given by sigma x plus sigma y by 2 plus root of sigma x minus sigma y square by 2 plus tau xy square, and the angle at which it is acting is tan 2 theta is equal to 2 tau xy divided by sigma x minus sigma y, where what is sigma x? Sigma x is stress in x direction, sigma y is stress in y direction, and tau xy is the shear stress acting on xy plane. Another formula is sigma x dash and sigma y dash. Now what do you mean by dash, x dash and y dash? It is the stresses at any angle theta. It is a stress acting at any angle theta, that is sigma x dash and sigma y dash. Now the important thing which we have studied in your regular classes is the Mohr circle. So let me explain something about Mohr circle. Now Mohr circle basically gives you all the values, that is sigma 1 principal stresses. It gives you what is tau xy. It gives you what is normal stresses. It gives you what is sigma x and sigma y. Everything can be found out from the Mohr circle. And what is the procedure to draw the same? It's very simple. First, you need to locate what is sigma x. So let us say I located sigma x here. Let us say its value is 10. Then I will find out what is sigma y. Let us say sigma y is given to us minus 5. So I will locate here as sigma x. This is sigma y. Now, let us say that tau xy value is given to me as 15. So I will make tau xy 15 here, and I will just join this. So this will become my radius of the Mohr circle. So taking this as radius and this as center, I will make a circle out. And this circle is nothing but the Mohr circle. So this is how the Mohr circle is drawn. We can find out maximum of the values from the Mohr circle, and you can observe here that the tau, the shear stress acting is nothing but the radius of the Mohr circle. So radius of the Mohr circle gives you tau. That is the maximum shear stress acting on that plane. And the angle at which it acts is nothing but 2 theta. So again from here, without using the formula, we can find out what is the angle at which the principal planes are acting. So let us start with this. So now let us say with this basics, let us start with the MCQ part for this particular topic. So the first question is, if F1 and F2 are major and minor principal stresses, so it is given that sigma 1 is F1 and sigma 2 is F2. And we are required to find out what is the maximum shear stress given by. So we have the formula tau max is equal to sigma 2 minus sigma 1 by 2, which is equal to F2 minus F1 by 2. And the option is B. Let us go to the next question. It says, principal stresses. Principal stress is the magnitude of dash stresses acting on a principal plane. So by the definition of principal stress, what we told, it is a plane at which shear stress is zero. That means there is only normal stresses. So I can write, so there is no question of shear stress coming into picture. So this option is ruled out. This says both A and B. This is also ruled out. So the only option is normal stresses. So answer is option A. Next question. The planes which have dash stresses are known as principal planes. Again, same question, just the reframing of the words. So we know that the planes at which so we know that the planes at which there is no shear, that is known as the principal plane. So option will be option C. Next question. Maximum shear stress is greater than radius of Mohr circle, smaller than radius of Mohr circle, equal to radius of Mohr circle, and none of this. So while explaining the Mohr circle, I have told you that if this is the Mohr circle, the radius of this Mohr circle gives you the maximum shear stress. So the answer will be equal to radius of Mohr circle, which is option C. Next question. The magnitude of maximum shear stress will be. So it's quite simple. It's directly formula application that tau max, if I go from the formula base, not from the Mohr circle, I have tau max is equal to plus or minus half square root of sigma x minus sigma y square plus 4 tau square. So directly, if I can see from the options, it is, I think, this one, option A. So this sigma x minus sigma y square plus 4 tau square raised to half. That means square root is taken care of, and it is 1 by 2. So yes, it's option A. Then next, when a body is subjected to biaxial stresses, direct stress sigma x and sigma y in two mutually perpendicular planes, accompanied by shear stress tau square, then maximum normal stress will be. So in previous slide, we have seen what is the maximum shear stress. Now we will see what is maximum normal stress. So again, I will write the formula. Sigma maximum, that is normal stress, is equal to sigma x plus sigma y by 2 plus half of the same sigma x minus sigma y square plus 4 tau xy square. So you can see this part is similar. Just we have to add this part. That is sigma x plus sigma y by 2. So again, referring to the options, I think this is the correct one. Yeah, this is the correct one. Sigma x minus sigma y, no. Sigma x minus sigma y, no. Oh, the option first is correct. Sigma x plus sigma y by 2 plus half square root of sigma x minus sigma y square plus 4 tau xy square. So this is option A. So we have now studied two formulas, tau max and sigma max, by also with the MCQs. Next, if a body is subjected to stresses in extra plane with stresses of 60 Newton per mm square and 80 Newton per mm square acting along x and y axis respectively. So I am given with sigma x is equal to 60 Newton per mm square and sigma y is given to me as 80 Newton per mm square. Also the shear stress tau xy is given to me as 20 Newton per mm square. Find the maximum amount of shear stress to which body is subjected. So previously we have studied this part. The formula for tau xy is equal to plus or minus half square root of sigma x minus sigma y the whole square plus 4 tau square. I told you to remember this formula so that we can apply. So here we are applying it. So is equal to half square root of sigma x minus sigma y. So it will be 80 minus 60 the whole square plus 4 tau square. So it will be 20 square. So if I solve this entire term, I will get answer for tau xy as 22.36. And if you see the unit here, find the maximum amount of shear stress is there. So units are wrong. It should be Newton per mm square. So all the units given are wrong here. So it should be 22.36 Newton per mm square, which is this one option. Same question is there. Everything same, but now we have to find out what is, find the inclination. Okay, find the inclination of the plane in which shear stress is maximum or maximal. So we need to find out the value of theta. So again, in the first slide we have seen tan of 2 theta is equal to 2 tau upon sigma x minus sigma y. In the first slide in LMR I have shown you this. So we get therefore tan 2 theta is equal to 2 into tau is 10 divided by sigma x is 60 and sigma y is 80. So I will get 20 divided by minus 20, so it will be minus 1. So tan of 2 theta is minus 1, so I will get theta is equal to 45 degrees. So option is option A. Again same logic or same question, sigma x is given, sigma y is given, tau is given, and we need to find out maximum normal stress. So we have the formula sigma is equal to, everything even same, sigma x plus sigma y by 2 plus half square root of sigma x minus sigma y by 2 the whole square plus 4 tau xy square. So if I see the previous example, I have the value of this part, that is 22.36. Same. So I will write here. Okay, let me substitute it. So it will be sigma x, that is 60 plus 80 by 2 plus half of square root sigma x minus sigma y. So it will be 60 minus 80 by 2 the whole square plus 4 into 20 square. So if I solve this entire expression, I will get the answer for sigma resultant as, sigma, that is maximum normal stress, as 92.4 Newton per mm square, which is option number B. So this is the answer. Let us go to the next question, which says, in Mohr circle method, compressive direct stresses is represented on. So just for the reference, I have given you this. This was not in the question. I have given you this for just reference. So you can see here that compressive direct stresses is represented on. So this is origin. From origin, it is sigma at the positive direction. So if it is compressive direct stress, it will be towards left side of the origin. So I will write it will be on negative x-axis. You can see sigma x and sigma y are plotted on x-axis and tau xy is plotted on y-axis. So tensile positive x, compression negative x. Answer will be negative x-axis. Next question. A plate in a strained material is subjected to direct tensile stress of 200 Newton per mm square, accompanied by shear stress of 50 Newton per mm square. So tensile stress is given, so I will given sigma x is 200 Newton per mm square, and shear stress, that means tau xy is given as 50 Newton per mm square. Sigma y, there is no data given about sigma y, so I will assume that sigma y is equal to 0. And we are required to find out what is sigma 1 and sigma 2, not sigma 1 and sigma 2. Find the value of major principal stress. So major is sigma 1. So I am just required to find out what is sigma 1. So I have the formula sigma 1 is equal to sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 the whole square plus tau square. It's a similar formula which we have used earlier, just it was 1 by 2 outside and it was 4 multiplied here. So it is 1 and the same. But now in this sigma y is given to us as 0, so this and this will go. So finally I will remain with sigma 1 is equal to sigma x by 2 plus root of sigma x by 2 the whole square plus tau square. So on substituting the values, I will get the answer for sigma 1, that is major principal stress as 211.803 Newton per mm square, which is option number A. Now let us suppose that in this question only, it was asked the value of major and minor. So what I have done, I will write sigma 1, 2, then I will write plus or minus, then I will get the answer for sigma 2 also in this particular formula. Hope you have enjoyed all the sessions and have gained something and have gained some knowledge in the topic strength of materials. Thank you.